Hello, this is Nikki Jackson, one of the instructors at Southwest Tennessee Community College, and what you see right now are some examples taken from Module 2 in Math 1530. So this video is going to do a brief explanation of certain problems from 2.1 and 2.2. Students who are currently enrolled in Math 1530, please be mindful that some of the problems you will have to do independently because I cannot discuss them due to time restraints. So hopefully you can see this. This particular one, you see a bar graph of one of the words that I see, or words that I see, are symmetric, uniform, skewed left, and skewed right. So I see those for right now. But before we start talking about what the bar graph represents, let's have a better understanding of skewness. So I'm writing as we do that. So hopefully you can see me as I write. So by definition, skewness is the sudden change of direction. In regards to statistics, it's dealing with the sudden change pertaining to the x-axis and the y-axis. So what I'm doing, I'm going to draw some curves. So when we get to modules 4 and 5, it's going to be called the normal bell curve. So realistically, I'm trying to give you a visualization of it. So that would be more so like the bell that you see ringing during Christmas time or Mississippi State fans at cowbell. So it always has a curve. Where this particular one right here, notice it has a big hump or a curve on the left-hand side, but it suddenly changed direction from the right. So this right here is considered skewed right because it has a tail on the right. Again, this is considered skewed right because it has a tail on the right. This also represents measures of central tendencies. We know measures of central tendencies to also be the mean, median, and mode. So notice how the mode is the tallest one because that's the one that appears the most. The medium is your middle, and then your mean is your average. So remember, this is considered skewed right because it has a tail on the right. Where it's the opposite of that, again, you still pertain to the x-axis and y-axis, you will also have skewed left. So skewed left will have a tail on the left-hand side and a big hump on the right-hand side. So you're looking at the tail on the left. So this one is skewed left. And this is a sudden change of direction. Once again, you still have your mean, median, and mode. So once again, the mode is going to be the furthest to the side because that's the one that appears the most. Then you have your medium, which is in the middle, and then your mean, which is on the average. So hopefully you can understand my squiggly squiggly. If not, please feel free to pause and rewind the video. Then we have the most common, or common. That is considered a normal bell curve. So once again, you got your x and your y. So your x is horizontal, y is vertical. But when it's time for you to do a normal bell curve, it almost looks like a big mountain or big hump. Well, this is significant because it's also considered symmetric, meaning that your mean, medium, and mode will all be the same number. Now, the reason why it's considered symmetric is because notice how, if I drew it perfectly, I'm not the best artist, y'all. Directly down the middle, you will have the same amount on both the left and the right. Hence, it's considered symmetric. Then we have one that's not even pertaining to a curve, but more so to a bar graph. Now remember, I'm not the best artist. So once again, you got your x and y axis. If I drew a bar graph, straight line, so you're going to have at least 5 bars right here. 2, 3, 4, 5. To the best of my ability, I tried to get them all the same height. Therefore, this one is going to be called uniform. because they're all the same height. In regards to measures of central tendency, which is your mean, medium, and mode, most of the time the mean and medium do not exist because they're all the same value. So your mode definitely will, because by definition your mode is the number that occurs the most. Now let's go back to our bar graph. And you can't see it, so that's not helpful. There we go. So there goes our bar graph. Well, hopefully you were able to write down those types of skewness. And notice how it has a tail on the left-hand side. So because it has a tail on the left-hand side, we know that it's going to be skewed left. Now the question is, which one of these answer choices is it? So using process of elimination, we only see one that has skewed left. So hopefully you were able to read all of those. So your correct answer would be C. So you're going to hear the paper turn. So now we're getting into words that we actually know. I call these M&Ms, but the proper term for these will actually be called measures of central tendency. You may have heard me talk about this previously. And the reason why they're called central tendencies is because notice how the mean, median, and mode were clustered together when we were drawing the bell curves for the skewness. So one of the ones that we hear quite often is the mean. The formula would be the sum, that's what the sigma sign stands for, of your data points divided by your total. So we know it's the sum of data divided by, that's what the fraction stands for, the number of data points. The word data can be either your numbers, your points, sets. It's always called something different. But the most common way that we know it as an average. Where you add them all up and divide how many you got. Your next one is going to be your medium. Now your medium is the number that you see that's in the middle. The medium is the one that you see in the middle. So hold on for a minute. Now here's the thing about the medium. So my apologies for the awkward silence. The medium is going to be your middle number, but you can have two middle numbers. You also have to put your numbers in order from least to greatest. Middle number wants numbers or data is arranged in order from least to greatest. Well, here magnify the bit, y'all. So let me zoom out just a little bit. There we go. There is possible for you to have two mediums. So if there are two middle numbers, you're going to add those together. My markers are going right now. So let me just stay with the same color though. There we go. So you're going to add those together. And then divide by 2. So since it's two middle numbers, add those two middle numbers together and then divide by 2. But remember, you have to put them in order from least to greatest. Then you have your mode. Now your calculator won't do your mode. By definition, that is the number that occurs the most. That means the one that you see the most times. You can have more than one mode. Just make sure that those modes appear the exact same number of times. You can have more than one mode. So hopefully y'all see that. So again, my handwriting is not the best, but we're going to make it work. Y'all make it work. So this would be the ideal time for you to pause and take a screenshot of this, because I'm going to have to keep moving. So alright. I'm going to find my measures of central tendencies now. So hopefully you're able to skim over this quickly. Notice that it's asking for the mean, median, and the mode. So again, we're dealing with measures of central tendency. There is a video that is posted in Pearson that I encourage you to watch showing you how to use the calculator. For time purposes, I will use the calculator and not do this manually, just for the purpose of time. So one of the first things you want to do is cut your calculator on. Be mindful, different people have different versions of this, so if you need any assistance, send me an email, give me a screenshot, or just wait till we get to virtual class, whatever the case may be. But all the calculators pretty much follow the same steps. Just be careful of what you need to press, especially if you're using the digital version on your phone. So once we cut this on, we hit our stat key, go over, nope, you don't go over, hit enter for edit. Now I have numbers in mine, so I'm going to use my up arrow key and hit clear, and hit enter. Use my right arrow key, go up to L2, clear, then hit enter. Now I'm going to put these numbers in. So we got 62, 41, 39, 42, 50, 42, 35, 52, 43. So I have my numbers in. I'm looking for the mean, median, and mode. Well, just by looking at the numbers, the number that I see that appears the most, 42, 42, do you guys see any other number that appear more than once? More than twice? Alright, so 42 is going to be our mode. So I'm going to move this out of the way and jump down here and say 42. But now let's figure out how to do a mean and median. So if you're doing it by hand, you're going to add all of them up and then divide by 9. If you're doing it by hand. If you're finding the median by hand, you put them in order from least to greatest and find the middle number. But since we're using a calculator, still on your list, hit stat again. Use your right arrow key. Go to calculator. So let me do that again. So I'm still on my list. Go to stat. Use your right arrow key. Go to calculate. We only use one list, so hit enter for one variable stats. Now again, as previously stated, different people got different calculators. If you just see this across your screen, just one variable stats, hit enter. If yours looks like mine, L1 should appear. Hit clear. Once you go to your down arrow key, hit clear, because there should be absolutely nothing for L2 or for your frequency list. Go down to calculate, hit enter, and we have the exact same numbers. So for our mean is represented by X bar. Our mean is represented by X bar. Our medium is going to be represented by MED. That does not mean medicine, that means your medium. So be careful when you do this, because I may have made a mistake in putting the wrong number. But it's asking you to round to one decimal place. So that 1 is not going to affect that 1. So you're going to have 45.1. Those of you using a different version of the calculator, you might already see MED. So great, awesome, yay! In this case, we're going to use our down arrow key until we can't go down anymore. We're looking for MED. So now we got 42. But we're not quite finished with the problem itself. Now be mindful, we're dealing with measures of central tendency. Measure of central tendency. Measures of central tendency. Yeah, I have to keep emphasizing that. Well, it will be this part. The mean represents the center. Because you remember, it's called measures of central tendency. Be careful, because different things have different stuff. Now, if you read this carefully, it says the mean does not represent the center because it's not a data value. You could use that, so this is an option. Ladies, gents, individuals, my apologies for not going to clarity for that, but again, because of time. But generally, it does represent the center because it's a measure of central tendency. The same thing for the median. It also represents the center because it's a measure of central tendency. Make sure you read all of them carefully as well. Then this last part. Now, the mode definitely would not always be a measure of central tendency because the mode itself is kind of an outlier because it's the number that occurs the most. By definition, an outlier is a number that just stands out. It either can be too big or too small. So in this case, notice how your median and your mode were the same number. So this also represents the center of data. But be careful with the mode. The mode will not always be that. So again, I'm moving right along. Now here goes one that we actually use at Southwest to find the grade point average. So take a moment to read it. So that awkward silence that you just had was for you to read this. So by definition, to find the mean grade point score, that's the same thing as your grade point average. You're going to have the sum of the number of points times the number of credits times the number of classes. So I'm going to show you a different way, and I just try to squeeze it all in. So that's just the numerator. The denominator now will be the sum of the number of credits times the number of classes. So the way I'm going to do this is going to be a little bit different. But make sure that you're able to zoom in. Let me do that as well. I got a glare. So hopefully you guys will be able to see it. So if I read it carefully, I noticed that an F was worth 0 points. Aha! F is not even on there because it's automatically assumed that it is 0 points. While an A is worth 4, B is worth 3, and C is worth 2 points, D is worth 1. So we're going to look at it from left to right and then vertical. So I'm looking at my B. I know a B is worth 3 points. You took 2 classes. Yeah, that order is wrong. We got to be in. And then that credit was worth 2. Let's look at the A now. The A was worth 4 points for 1 class times 3 credits. Plus, and this is the ideal time for you to pause or rewind if need be. A D was worth 1 point times that 1 class times its 2 credits. So again, I wrote it in the wrong order, but here's the thing. Multiplication and addition are both cumulative. Commutative, I said it wrong. Commutative, meaning they're reflective. So no matter what order you put it in, you still get the same answer. And then we got C. C is worth 2 points times that 1 class times those 3 credits. So this is all your numerator. Now we're going to do a denominator. That's your number of credits and your number of classes. So I got 2 classes worth 2 credits plus 1 class worth 3 credits plus 1 class worth 2 credits plus 1 class worth 3 credits. So reading is fundamental here. So now we're going to simplify this to the best of our abilities. Then we're going to try to use our calculator. This is a lot. So 3 times 2 is 6, 6 times 2 is 12, 4 times 1 is 4, 4 times 3 is also 12, 1 times 1 is 1, 1 times 2 is 2, 2 times 1 is 2, 2 times 3 is 6, 2 times 2 is 4, plus 1 times 3 is 3, plus 1 times 2 is 2, plus 1 times 3 is 3. So we're going to try to simplify all of this now. So 12 plus 12 is 24. 24 plus 2 is 26. 26 plus 6 is 32. So guys, I'm human. I make mistakes all the time. So make sure that I did that because I was on the middle now. 4 plus 3 is 7. 7 plus 3 is 9. 9 plus 3 is 12. So now we can use our calculator. So divide 32 by 12. We should have gotten 2.66666666. So I'm just going to draw a bar over it because continue. Then it says round to the nearest tenth. So that 6 is going to make that other 6 is 7. So your final answer is 2.7. So again, make sure you do a similar question when it's your turn to do this so you have a better understanding, and feel free to stop and rewind the video. On to the next. So this one kind of looks like a dot plot. At least that's what I call it because it's a number line full of dots. But I noticed my definition is dealing with something called range. So your range by definition is how spread out your data set is. The easiest way to measure that is the largest number minus the smallest number. So again, the range is how spread out your data set is. In this case, I have to pay close attention to what my data set is. So I'm looking at these numbers right here. I know my smallest number is 70 and my largest number is 100. But I can't find my range right there because there's no dot here. So it looks like it's a dot at 96, 97, 98. So that's going to be my largest number. And then my smallest number is 71, 72, 73, 74. So let's subtract them. So what is 98 minus 74? You should have gotten 24 for your range. So I wanted to go over this because a lot of times we just want to use 70 and 100 because those are your largest and smallest. But those are not the ones that have the largest and smallest dots. Again, here's something else dealing with measurement. Now we're looking for the range, the mean, the variance, standard deviation of the population data set. Keyword is population. Okay, so let's go back over some definitions again. We just went over the range. So the range is the measure of how spread out your data set is. So we got our largest number minus our smallest number. But then I see something called mean, where your mean, we know that as our average. But for the sake of time, we're going to use our calculator. So it's going to be represented by X bar. But now we got something new, something called the variance and standard deviation. Well, there are different kinds of variance and standard deviation. You have your population variance. Meaning that you will also have a population standard deviation. Now you may remember from Module 1, oops, that's what I'm saying. There we go. That a sample was a subset of a population. So that means we also have a sample variance, and we also have a sample standard deviation. So both the variance and standard deviation also measure the spread of the data, but they primarily focus on the mean. The easier way that I understand it is like a margin of error. So they give you a little bit to go over and a little bit to go under, but it's only so much they can do. Very similar to when you curve your grade. A more applicable concept of this would be your boundaries that we did in Module 1. If you remember the boundaries were only 0.5 below the lower limit and 0.5 higher than the upper limit. So that's what the variance and the standard deviation are. They're like little small numbers that we can measure the spread. So let's apply this. Oops, no, let's not. Just think about these symbols now. So population variance, you're going to be looking for OX squared when we're using a calculator. For population standard deviation, you're just looking for OX. So the O represents population. When you're looking for sample variance, you're looking for SX squared. And then you're looking for XX. So you may notice that the variance, let me scoot it up a little bit, hopefully you can see it. The variance is your standard deviation squared. The variance is your standard deviation squared. Ladies, gents, individuals, the variance, it can be computed in the calculator, but it's easier for us just to do the standard deviation, write it all out, and then square. So let me show you what I'm talking about. So let's go up here. So we know our range is the largest number minus the smallest number. So it appears that our largest number is 15 minus 2. So now we have, what is that, 13 for our answer. Then the population mean, which we have not done yet, because we're going to use the calculator for that one. So the first thing we're going to do is cut it off. Because we are in introductory statistics class, we're going to hit the stat key, hit enter for edit. Use your up arrow key till L1 is highlighted, hit clear, and hit enter. Again, if I'm going too fast, make sure you pause and rewind the video. Now we're going to put our data set in. So we have 2, enter, 10, enter. Notice how I'm hitting enter. It's trying to put my number in. Also, this video should be posted or something very similar to it already in Pearson. So once I put my numbers in, I'm going to go back to stat, go to calculate, because I only use one list, hit enter for one variable stats. Once again, depending on what version of the calculator you have, if you just have one variable stats on your screen, hit enter. If yours looks like mine, make sure that your frequency list is clear. So we're going to go down to calculate, hit enter, and voila, we have our answers. So for your X bar, which is your mean, it says round to the nearest tenth. Well, it's already rounded to the nearest tenth forward, so we got 8.7. For your variance, notice how there is no OX listed. There is no OX listed, but there is an OX. So we're going to write all the digits down as you see for OX. And this example is a very short one today. But when it's your turn to do it, make sure you write down all the numbers for OX. This is just a short one for them. So we're going to do 4.1 squared. The standard deviation we've already done says round to the nearest tenth, which is the 4.1. But now we have to do the 4.1 squared. Yes, I'm jumping all over the place, but hopefully you'll be able to follow. So I got 16.8. It's asking me to round to the nearest tenth. So our variance is 16.8. So instead of saying 16.81, you're doing 16.8. So again, please feel free to pause and have a better understanding of this. And you have to read carefully to know when you're going to be using population and sample. In this case, I knew I was using a population. When it's your turn, it might say sample. Here's another one requiring us to organize our data visually. This is called a box whisker plot, because notice how you have your whiskers on the outside and then your box in the middle. This is also known as the 5-number summary. So let me show you why. So if you read it carefully, you see the word quartiles. Well, I'm going to use the dollar to explain this, because we like money. So you got 0, and then you got 1. We're going to speculate that everybody knows how to count money, or U.S. dollars in this case. So half of a dollar is called 50 cents. Notice how I said half of a dollar. So we also know that is our median. Your median is also going to be known as Q2. Well, median you can understand, because that's the middle. The Q2, well, let's understand where that comes from. Well, let's look at the lower half of our dollar. So you got 0 up to 50 cents. Well, what's the halfway mark of 0 and 50. So that's going to be 0.25. So we know that as Q1. So Q1 is the middle of your lower half. Q1 is the middle of your lower half. Now be mindful, I'm using this as a metaphor with the dollar. Now we're looking for the middle of the upper half. So if you can count your money, you know that's going to be your 75. So now that one is going to be considered Q3. Well, if we're still thinking about the 5-number summary, that makes your 0 your smallest number, which is your minimum, and the 1 your maximum, which is your largest number. So the 5-number summary, 1, 2, 3, 4, 5, is your minimum, your Q1, your medium, Q2, and your maximum. So very similar to what we can do with a box whisker plot, which is going to represent it. So if you're doing a visualization of it, this is your minimum, that's your maximum, this is your Q1, this is your Q2, and this is your Q3, and that's your Q2 in the middle. So it's not quite in the middle, it's very confusing, but that's the concept. So the whiskers are your minimum, your maximum. The outside of the boxes are your Q1 and your Q3, and the inside of the box is your medium. So let's actually look at this problem to figure out if we can actually do that, which we can. Once again, these videos are posted in Pearson, so be careful when you watch them. I know they're boring, but just try to do it anyway. So I'm going to put it on, go to Stat, hit Enter for Edit, use your up arrow key, hit Clear then Enter to clear out your list. So we got 20 numbers that we have to enter in. So 7, 8, 7, 1, 3, 9, 9, 4, 0, 8, 9, 3, 8, 10, 1, 1, 4, 5, and 6. You may not type as quickly as I did though, but that's okay. Feel free to pause. But we have a total of 20 numbers. Even though you see 21 right here, notice how that line is blank. So my very last entry, it does say 20. So now we're going to go back to Stat, go to Calculate. Because we only use one list, we're going to use one variable stats. So hit Enter. Remember, if yours just has one variable stats, you hit Enter. If yours looks like mine, make sure your frequency list is clear. Frequency list, not list. There, I want you to be right there. So go down to Calculate. We see our mean, but we don't see Q1, Q2, and Q3. So depending again on what version of the calculator you have, if you have the digital version, all of it should appear on one screen. But for this one, I'm going to use my down arrow key so I can't go down anymore. I know that my Q1 is 3.5. Q2 is the same as your medium, as indicated down here that you can't see. There we go. Boom, bam, pow. So 6.5. And your Q3 is 8.5. Ladies, gents, individuals, I could have made a mistake and we got different numbers, so check behind me because I am going kind of fast. But we're not done yet. We have to draw these. So this calculator is awesome. But before we do that, I'm going to do process of elimination. I can cross out B already because notice how that line is not in the box. It always has to be in the box. So now we're left with A and C. Well, here's my calculator still on. Notice I'm on blank screen. Hit your second key and Y equal. So let me try it again. Second key, Y equal. Hit Enter. So if I move too fast, please make sure you pause and rewind. Notice how you're on a new screen now. So we're going to hit Enter to make sure that your plot is on. If your other plots are on across the top, meaning that they're darkened, make sure that they're off. So if you see them dark, just hit Enter and they automatically change. But we only want plot 1 to be dark. We also want a box whisker plot. How do I know? Because that's what they showed me. So once you hit Enter for on, use your down arrow key, then your right arrow key. Pick the second box whisker plot. So you're using your down arrow key and your up arrow key. Pick the second box whisker plot, hit Enter. Notice how it automatically changed for you. Go to Zoom. Go down until you see Zoom Stat. Because remember, we're an introductory stats class. So use your down arrow key until you see Zoom Stat. Those of you who are using your cell phones for this, once you hit graph, Zoom appears in the lower left-hand corner. Zoom appears in the lower left-hand corner. So let me show you what I'm talking about. My graph is not going to look anything like this because I didn't do it. So after you put all your data in, hit graph. My graph does not look like yours because I didn't put it in. But hit the word Zoom in the lower left-hand corner. Then hit Stat. That's just for those who have a phone. I know mine does not look like yours because I did not put my data in. So once you hit Zoom Stat, boom, bam, pow, that's what you get. Now I have an extra line right here, so I'm going to go over here to y equals and hit clear. So now I'm going to go back to graph using process of elimination. Which graph do you think it's going to be? Is it going to be A or C? Using deductive reasoning, we're going to say that it's going to be C, because notice how there's a long tail on the left-hand side right here versus it's a long tail on the right-hand side right here. So again, if I'm going too fast, please make sure you pause and rewind so you can go back over that. Right, now I'm going over some sections from section 2.2. Ladies, gents, individuals, I wish we were meeting in class or face-to-face, but we're going to have to be intrinsic learning, meaning that a lot of stuff we're going to have to do on our own. So I'm going to help you while I can and while time permits. So now we've jumped to 2.2. 2.2 is dealing with linear regression. So in regards to linear regression, let me explain a few things. If you remember anything from algebra, you may remember this point right here. So when you were in algebra, this was called slope-intercept point, where M was your slope and B was your y-intercept. Well, in statistics, we're going to do something very similar to that, except it's going to be considered your slope-intercept, not slope-intercept. It's going to be called your linear regression. It's going to look very similar to it, but it's going to be called linear regression. Your calculator will do this for you. You know that A is going to be your slope. Notice how it's attached to the X. We know B is going to be the y-intercept, where it's going to cross the y-axis when you graph it. But there's some more stuff that we need to understand about linear regression. We know linear regression is going to be a line. We can see that. See that part right there, the line part? What we don't understand is that linear regression is a relationship. So think about your husband, your wife, your girlfriend, your boyfriend. It's going right here. It's measuring a relationship. Statistically, that relationship is going to be between your X and your Y. So here are your unknown variables. So the linear regression measures it. So it's letting you know if it's positive or it's negative. It also tells you how strong it is. That strength is measured by R, which is called your correlation coefficient. So what we're focusing on is the measure of the relationship between X and Y. So let me show you what I'm talking about. So linear regression itself. Once again, we know we're measuring between X-axis and Y-axis. Well, here's a bunch of data points. They're just all over the place. But notice something about them. If I was to draw a straight line between these, some of the dots are on there, some of the dots are not. This would be considered a strong positive relationship. The reason why it's strong, because you have quite a few dots that are actually touching or near the line. The reason why it's positive, because it's going upward. It's going upward. So that means that your R is going to be somewhere between 0 to positive 1. So the closer to the 1 it is, the stronger it is. So if something can be positive, that means something can also be negative. Hopefully everybody's tested negative for COVID so far. If not, that's okay. I hope you have a smooth recovery. People in my household struggle, but hey, we're doing it. This is considered a strong negative. So notice how you had a bunch of dot points. Some are touching the line, some of them are not. The reason why it's considered strong, because some of the points are actually touching the line. The reason why it's negative, because notice how there's a trend of it going downward. That means your R correlation, or your correlation coefficient represented by R, can either be 0 to negative 1. So let me rewrite this. So 0 to positive 1. 0 to negative 1. Then we just have relationships that just are non-existent. So then you got your X and your Y. And they're all over the place. This line can be either going upward, downward, or just none at all. So when you can't determine what it is, you assume that it's no relationship. Because you can't measure it. It's non-existent. So we're looking at either a positive or negative relationships. So that's all dealing with regard to linear regression. So let's go back to how the calculator figures out this R. Well, first, we're going to put our calculator on. Get clear in case you have something on it. You will only have to do this one time unless you change your batteries or reset your calculators. You only have to do it one time. So I'm hitting my second key, then 0. Second key, then 0. Go all the way down until you see diagnostics on. Go all the way down until you see diagnostics on. Alright, so there diagnostics on. There it is. On, not off. Hit enter. Hit enter again. Nothing magical happened. So if I was going too fast, please feel free to pause and rewind. Again, nothing happened. Just want to make sure it's on. Now what it just did was, in your calculator for linear regression, it identified what your R correlation coefficient was. But we don't know that until we get to that point. Meaning, here's an example. So here's an awfully long problem. Notice how it has multiple parts. So take a moment to look at that. Pay close attention so you have your regression equation. So here it is right here. We have to figure out what that is. So using the information given to us, first thing we're going to do, put our calculator on, hit stat. Hit enter for edit. Clear out your list 1. Clear out your list 2 if you have any data. Your L1 will always be your X values. Your L2 will always be your Y values. So let's put under this one, let's put in all our X values. So 1, 2, 3, 4, 5, 6. Using your right arrow key, let's go over to L2 to put in our Y values. So 39, 44, 50, 47, 61, 71. So we got all our numbers in. Yay! Go to stat. Go to calculate. Do not hit second variable stats. I know you want to. I know you really want to. Because you use 2 lists. But we're not. Because it is distinctively asking you to find the regression equation. So we're going to go down to number 4. It may not be 4 in some of your calculators, but make sure you're looking for linear regression right here. The AX plus B. So hit enter. Notice how your lists pop up. So L1 and L2. If your calculator does not look like mine, that's okay. As long as you got linear regression across the top, hit enter. If yours looks like mine, make sure your X list and Y list are labeled as L1 and L2. Go down to calculate. Look at there. Notice how it also gives you your R correlation, which is just R. So some of those problems in Module 2, in Section 2.2, I didn't cover, but make sure that you do the exact same steps for this. So now, we're going to write out our equation. So make sure that we read it carefully. It says round the slope 3 decimal places. So 1, 2, 3, that 4 is only that 8 is 8. So that's 6.288 for your A. Then it says round the y-intercept to 2 decimal places. So that 8 is going to make that 3 or 4. So now we're going to have 31.04. So we got that. Hit clear. Hit your Y equal key. What we just wrote down, we're going to type it in now. So we have 6.288. Notice where my finger is for the variable x. I have to include x because there is part of the equation. So x plus 31.04. Hit enter to lock it in. Second, y equal. Hit enter. Now we did this earlier for the Box-Whisker plot, but we want to do it a different plot now. So hit enter to have it on. So which one do you think we're going to use? Using deductive reasoning, we're going to say the dot. So going down and hit enter. How did I know to use the dot? Because guess what I see? I see dots. This one is more like a trend line. Same thing with this trend, T-R-E-N-D. So I'm going to hit enter for that first one. Enter. Go to zoom. Go down to zoom stat. Hopefully those of you remember earlier how to use your cell phone to find zoom. And there it is. Again, feel free to pause it and rewind. A similar video is also posted in Pearson already. Using process of elimination. I know I can't use A nor D because this line is going up. So looking very carefully at B and C, well, let's look at the number of dots that are below and above it. Looking at this carefully, looks like it's only 2 dots below the line, which is like all the dots below the line. So we're going to say it's going to be B, not C. But wait, there's more. Remember, this is a multiple part problem. Now we're going to use our equation and substitute our values in. So going back up here, we have to substitute the values of 4, 3.5, 14, and 1.5. Well, notice how these are your x values too. So let's look at our x values. We got 1, 2, 3, 5, and 6. Wait a minute. They say that's 14. 14 is not even listed up here. In fact, 14 would be considered an outlier. So for this one, we're going to say it's not meaningful. It is too big. You would do the same thing if you found a number that was too small. Be very, very careful with this part, ladies, gents, individuals, because even if you substitute it in, it will give you the answer. It will be listed down here, but it won't be the correct answer because it's not meaningful. It's too big. 14 falls outside the range of that. So now that we've looked at all our numbers, they fall between 1 and 6, we can substitute them. So now we got 6.288 times 4 plus 31.4. So we're substituting our values for x. And we have 62.88 times 3.5. Even though 3.5 is not up here, 3.5 does fall between 3 and 5 plus 31.04. Again, you can substitute this. You can get an answer, but it won't be the right answer. So we're going to go to D, substitute 6.288 times 1.5 plus 31.04. I'll just squeeze that out in here. Sorry about that. So let's see what we can do. We got 6.288 times 4 plus 31.04. My answer is close as possible and rounding it with B. Doing the same thing for your next one, 6.288 times 3.5 plus 31.04. Process of elimination, rounding, so it's going to be B. And then your last one. You're going to have 6.288 times 1.5 plus 31.04. Substituting, round it, it's going to be C. So awesome. So again, feel free to pause and go back over the video for me, okay? Alright, thank y'all for watching.